we need to prove that the surface integral of cross product of r vector with n vector is 0 for any closed surface S. Now here, I need to apply the Gauss Divergence Theorem, but how can I apply on this surface integral? Because for that, I need something to be having the dot product with n vector, then only I can apply the Gauss Divergence Theorem, right? So for that, what I have to do is, we have to consider any constant vector A vector, let's suppose, and taking its dot product with this surface integral, so that we can reach something of the form of the surface integral having its dot product with n vector ds. Then we can apply the Gauss Divergence Theorem and get the result to be equal to 0. Okay, let's move on to the solution. Let V be the region enclosed by the surface S, and we need to suppose a constant vector. Let's suppose A vector be the constant vector, and then we need to consider its dot product with the given surface integral. This is equal to, just take this A vector and its dot product inside of this integral. And then what we do is, it is a result, shift this dot to this cross and shift this cross to this dot. So we get the surface integral of A vector, its cross product with r vector, and in place of cross we are writing dot n vector ds and taking this in bracket. And now we are having the surface integral of this format of the integrand, and now we apply the Gauss Divergence Theorem, right? So by Gauss Divergence Theorem, the surface integral of A vector cross product with r vector, its dot product with n vector ds, this is equal to the volume integral of divergence of A vector cross product with r vector dv, right? So this is equal to the volume integral of, okay, what is the divergence of cross product of two vectors? This is the result, and many times I have evaluated this result. Please take this as your remark or remember the result. So this is second vector, its dot product with curl of first vector, minus then first vector, its dot product with curl of second vector. Remember? Easy to remember? Yes, easy to remember? Okay. Now curl of r vector is always equal to 0. You can evaluate this. Writing here partial derivative with respect to x, then with respect to y, with respect to z. Then writing the components of r vector as x, y, z. Because r vector is what? It is x I vector plus y j vector plus z k vector, right? So when you solve this, you get I vector into partial derivative of z with respect to y minus partial derivative of y with respect to z, minus then j vector, partial derivative of z with respect to x minus partial derivative of x with respect to z. Similarly, and then writing the third term, and we know that when we derivate z with respect to y, we get this to be 0. Derivating y with respect to z, we get 0. Derivating z with respect to x, we get 0. Derivating x with respect to z, we get 0. So all the terms coming out to be 0. So curl of r vector is 0. You can also take this as del cross r vector, and which is equal to 0. And curl of constant vector is also 0. So we get the volume integral of 0 minus 0, and this is dv, so that is equal to the volume integral of 0 dv, so which is equal to 0. So we have shown that this surface integral is 0, but we have got this surface integral initially from A vector dot product with surface integral of r vector cross n vector ds, that is equal to this, which is further equal to 0. That is, A vector dot product with the given surface integral is equal to 0. But A vector is arbitrary. We can use any constant vector, right? So writing here, but A vector was arbitrary And because a vector is arbitrary vector, it is having its dot product with this surface integral, which is coming out to be 0. That implies this surface integral is 0. So therefore, the given surface integral is 0. Alright, thank you. Stay blessed.